Before getting into the nitty-gritty detail of SIP behaviours and SIP messages, it's probably worth spending a few minutes to step back, look at the broader SIP network and introduce the 12 key components that you'll get to know during the course. The plan is to start with a basic call, highlight needs, and then one by one introduce the devices which meet those needs. So, need number 1. 2 users need to communicate over an IP network. How do they do it? With what tool? The SIP user agent. User agents are endpoint clients, equivalent to the good old house phone in traditional telephony through which we make and receive calls. Now, the user agent has 2 main tasks. First, it takes care of signalling to alert the other party. And second, it captures and encodes media and sends out the encoded data over the IP network. The user agent on the other side receives and decodes the media and represents it to the user. Now, like all IP devices, user agents send IP packets to an IP address. But what if the user agent doesn't have the other guy's IP address? Well, that's need number 2, that user agents have a way to discover each other's IP addresses. How do they do it? With help from the next 4 SIP entities: the registrar and location services, the SIP registry, and the proxy server. Here's how they work. As the other guy, Nathan, logs in, his user agent sends its IP address, together with Nathan's public dial address, to the registrar service, a core SIP component that simply takes the 2 addresses and stores them in the SIP registry, probably a database. Then, when I dial his public address, my user agent sends an invitation signal, not to Nathan's phone, it doesn't yet know its IP address, but to my provider's location service. It then queries the registry, retrieves the dialed party's IP address, and proxies the invite downstream to the phone. So, Dave didn't know Nathan's IP address when he initiated the call, but because of registration, the location server does. When Nath picks up, his response includes his IP address. So now, Nath having received my invite and me having received his response, both have each other's IP addresses and can begin exchanging media. Great. With a bit of help from the SIP registrar service, the SIP location service, and the SIP registry, and of course our SIP user agents, users can exchange media over IP without first knowing each other's IP addresses. But what about the SIP proxy server? What's its role? Well, note how I've been describing the registrar and the location roles as services rather than servers. Although they could be separate entities, they're most often embedded in the proxy as pretty much standard proxy behaviors. One server that serves registrar and location services, as well as the proxying of SIP messages. But today's communications need much more than just setting up calls. What about features and services, applications that do special things and provide added value? That's need number 3, features that enhance our communication experience. How do we get them? Through feature servers, the next of our SIP entities. Here's how they work. Take call forwarding, for example, the ability for my incoming calls to be forwarded perhaps to my cell phone when I'm out of the office. One approach is to simply build in extra capability, extra logic to the proxy, so that when an invite arrives, rather than query the registry, instead it checks for call forwarding rules and alternate routes to my cell phone instead. Okay, it could be done this way, but this approach kind of goes against the ethos of SIP. Rather than having everything in one product and perhaps mandate a dependency on the product vendor, SIP prefers a more distributed architecture. Move the application logic out to a separate device and add just some simple routing rules to the proxy. That way we can add in as many feature servers, applications as we like, each with their own special capabilities, each performing some special task. Separate feature servers give complete flexibility. Upgrades? Well, they're a piece of cake. Take out the old and add in the new. Want the latest new feature? Simply add it in and configure the routing rules. Nice. We're no longer dependent on a particular vendor for all our special features. So, call forwarding. Well, an invite arrives at the proxy checks the routing rules and this time routes the invite to the call forwarding feature server, which, after applying its logic and checking my profile, modifies the destination address inside the SIP message and routes the call downstream to the cell phone. With separate feature servers, different combinations, different sequences of applications can be applied for each user without a dependency on the proxy vendor to supply them. Cool. Now, there are some services that need extra facilities, like recording users' media, playing back recorded media, and collecting user input in the form of DTMF keystrokes. Press 1 for sales, 2 for support, and so on. That's need number 4, the ability to play and record media and collect DTMF input from users. Welcome to the next SIP entity, the media server. Now, the media server is a talented endpoint user agent that can record inbound media, play back those media recordings, and capture DTMF tones as the user presses keys on the phone. In fact, media servers also often serve as media bridge, taking multiple media streams from multiple users and mixing them so that all parties can hear each other, an integral function of conferencing. Now, the media server sits typically alongside the set of feature servers. You see, it's a reusable component that provides recording, playback and DTMF collection for all the feature servers, meaning they don't have to do it for themselves. Now, in our scenario so far, caller and callee both belong to the same domain, work.com. They both register with the same work.com registrar. The IP addresses for both are stored in the same registry. Both use the same location service, and feature routing is applied for both by the same work.com proxy. But what if I want to call someone on a different domain? That's need number 5, the ability to make calls between users on different domains. The reality is there will be for sure many different domains, each with their own proxy, including registrar and location services, their own registry, and each probably with their own sets of feature servers and media servers. So now when Dave makes a call to a user on another domain, well, just like before, the invite arrives at his proxy, but this time, on finding its address to another domain, instead of checking the registry, the proxy's task now is to find the other domain server and route the invite downstream. How? In the same way all IP devices locate another domain, with a lookup to the Internet Standard Domain Name System, or DNS. So after a quick DNS lookup, the invite's proxied to the elsewhere.com domain server, where, just like before, its SIP location service retrieves the IP address from the registry and proxies the invite onto the phone. Now, there might be times when, perhaps after a user moves to another domain and a call arrives for that moved user, a proxy might want to provide a forwarding address, but without getting involved in call signaling. In fact, that's need number 6, the ability for a server to provide forwarding addresses. And how does SIP make it possible? Through the redirect service. Having received an invite for someone who's moved domains, the redirect service simply passes back upstream the called party's forwarding address, allowing the upstream device then to reroute to that address if it likes. That's the redirect service. Like the registrar and location services, the redirect service could be a separate server, but more commonly, it's a standard behavior found in most good proxies. So in today's world, there are many different domains, many networks. Now, there's a difficulty to overcome. Sadly, there are some malicious folks out there who'd like to abuse these services given half a chance. Accordingly, network owners are hugely protective. They certainly don't want outsiders getting sensitive information, like server IP addresses that could be used for malintent. So, how does SIP protect its network from malicious abuse? That's need number 7, the ability to protect the internal network. Let's welcome the Session Border Controller, or SBC, a gatekeeper, a SIP device that sits at the network border and not only controls what comes in and goes out, but literally manipulates, changes SIP message content so that things like internal server addresses are replaced with non-routable dummy substitute addresses. Naturally, the SBC remembers its mapping so that when a response comes back, it swaps back in the correct details before routing the message internally. Being the entry point to the network, session border controllers often also watch out for and prevent things like denial of service attacks. Finally then, what about the need for a SIP user to call a non-SIP user, perhaps a traditional phone on the good old PSTN? That's need number 8, the ability to communicate with non-SIP users. Allow me to introduce 2 gateway devices, the signaling gateway and the media gateway. The signaling gateway is a signaling protocol translator. Take SS7, for example, the legacy PSTN protocol. The gateway takes a SIP invite on one side and constructs the equivalent SS7 I am message on the other, populating it with content from the invite and sending it out over the PSTN network. Then, when the SS7 ACM or AMN comes back, it translates them back into the equivalent SIP responses before sending those SIP responses through the SIP network. But even with successful signaling translation, what about media? It's quite possible that different networks use different, perhaps incompatible codecs to encode their media. So how do we make them compatible? With a media gateway. The media gateway transcodes media. It literally takes media streams on one side and transcodes them to a different format on the other. So there we go, an introduction to SIP's main components.